It is the bouncing of light or bouncing off or back of light from surfaces. Then we realize the extent of reflection. The extent or the way and manner a body would reflect depends on factors. One, whether the surface is so rough or smooth. When it's smooth, reflection is orderly or regularly. When the surface is rough, reflection is scattered. Now, then the nature of the surface. If the surface is solid, it can reflect more than when it is liquid and gaseous. Then it also has to do with, for somebody to see that truly reflection of light has taken place, we need to also look at whether the body is transparent, whether the body is translucent or opaque. Now, if the body is transparent, part of the incident light is reflected. Small parts of it is reflected. The larger part of it is refracted. Example, if you have louver blade isn't mirror, because when we are talking about mirror, one side of it must be coated. But if none of the two sides is coated, when you incident light on a louver blade, small part of it will be reflected, and then a greater part of this will be refracted. When the material is opaque, very, very small will be reflected. Then huge part of it would be absorbed in the material. It would be absorbed because it will not come out of the material for you to see that the refracted part, okay, the refracted light is coming out. You know, refraction is about bending of light. Here, light has to be bent. Its speed must change. We'll come to refraction. Now, when the material is translucent, parts, of course, parts will be reflected, some parts will be absorbed, and some parts will be refracted. Okay, so these are the conditions that affect reflection. But to talk about reflection, for greater reflection, then the surface must be so smooth. Okay, it being so smooth also means that one side of it must be coated so that it will be opaque. So when you have a louver blade and one side of it is coated, no parts, there will be no amount or proportion of the light passing through. We'll have greater percentage of it reflected. But even in this, the material to be used as a coating surface must be special, preferably silver. Silver is used in coating one side of a mirror, okay? Meaning if you don't use silver and any other something or material, it wouldn't reflect so much. All right. So this is it with reflection. Let's look at types of reflection. Types of reflection. We have two main parts or aspects of reflection. We have what we call as a regular one, and the types of reflection. And the types of reflection we have one, the regular or specular. There's, I think, I'm having reflection of the light here. So let me, anyway, it qualifies. We are doing reflection. So if I'm experiencing reflection of light, then that is in place. So we have regular slash specular reflection. Then the other type, we have irregular or diffused reflection. Can somebody tell me about what regular or specular reflection is? If you've read something on regular reflection, can you share with us what regular or specular reflection is? Can anybody? The guys, the ladies, can somebody share with us what regular reflection is? Okay, revoir. Revoir, I'm listening. Oh, revoir, go ahead, I'm listening.
Okay, Mr. Elia, please. It is when light is reflected from a
Revoir, your line is breaking. Hello. Okay. Revoir has issue with her network. Please, somebody else can share. If only you have the idea. All right. So regular reflection.
Okay. You can hear me now.
Revoir, sorry, your line is giving us trouble. So let me take over, okay? So regular reflection occurs on smooth surfaces. So this kind of reflection occurs on smooth surfaces such as the surface of mirrors. So occurs on smooth surfaces. Example, surface of mirror, well-polished surfaces, well-polished surfaces. Then surface of calmed water, the surface of calmed water, water bodies, well-polished floors, walls. So generally I say well-polished surfaces. So these are areas where regular or specular reflection is expected to occur. Okay, now how does it happen? So we have a well-polished surface. This is a well-polished surface. The coated part is this. Example, mirror surface. So what happened? Light, you see, and before we look at reflection. Let's look at rays. In physics, a ray of light, that single ray of light is represented as this bold line with an arrow at the middle. So this is a ray of light, or just a ray. Now, if we have several of them, okay, they form a beam. So beam of light has several individual rays. So they constitute a beam. So we can also describe this particular beam as parallel beam of light. Parallel beam of light. Then we also can have convergent beam. The rays or the beam of light are converging at a point. So this is convergent beam. Then we can also have beam of light that diverges. So diverging beam. Here, for convergent beam, they are all coming from a point and meeting at a point. The ray is, individual rays can come from a point or a source, and they all converge at a common point. Then, for diverging beam, they can all come from a common point and spread out. Learning. Your hand is up.
What was the definition of the ray?
Come again.
The definition of a ray.
A ray of light, okay, is a single pack of energy from a source. Okay, light is a form of energy. So when we are looking at a single bundle or pack of energy coming from the source, that is what we are describing as a ray of light. But when we are considering several of them, individual rays, then we have what we call a beam of light or a beam. So this is spiral beam or rays, convergent beam of light or rays, and then divergent. A ray is also can be described as a photon. A photon is packet of energy or packet of light. So parallel beam, convergent beam, and divergent beam of light. So if this is a smooth surface, well, or can be well polished, then we have beam of light incidenting on the surface. So we have beam of light, several rays incidenting on the surface. Let's use maximum 3 rays incidenting on the well-polished surface. Now they incident in a regularly manner. So regularly incident beam. Because this is a well-polished surface, when the incident on it, they will certainly reflect because mirrors reflect. So we have the reflected beam also in that orderly, regularly manner. So if you have several of them, let's add another one. We can have several of them, please. I'm not limiting the rays to only 3. So we have 4. The incident on the mirror in that regularly manner and also reflects in that regularly manner. So this is incident beam. Incident beam. And we have this as the reflected beam. So in regular reflection, this is a reflection which occurs on smooth surfaces. Examples are what we've mentioned. Here we have light or beam of light incidenting in that regularly manner. And because the surface is so smooth, the reflected beam is also in that regularly manner. Now, when you have regular reflection occurring on a surface, it brings about the formation of images, usually virtual images. So regular reflection brings about the formation of virtual images. And this is the reason why when you are walking on a well-polished floor, you could see your image on the floor. This is the reason why when you are walking alongside a river and the surface is calm, you could see your image. This is the reason why you could see your image in a mirror. So regular reflection brings about formation of images, virtual image. Please, any question? Now, in regular reflection, each of these individual rays obey the law or the laws of reflection. Each of these individual rays obey the laws of reflection. So we'll look at diffuse or the irregular reflection. Then we'll look at what the laws of reflection is and move on. Please, any question? So advantages of regular reflection is that it brings about formation of images, but mostly virtual images. Okay. Now, irregular or diffused reflection. Irregular or diffused reflection. It's other pair, which is diffused or irregular reflection reflection occurs on the surface of rough or occurs on rough surfaces. Irregular or rough, so occurs on irregular or rough surfaces, such as walls, the ground. It can be the ground, anything rough, ground, walls, etc. Anything rough. Okay, so here we have an irregular surface. This indicates the irregular surface in question. So this macaroni-like thing represents irregular surface. What happens? In diffuse reflection, we have light incidenting in that orderly manner on the surface. So a single ray of light, another ray, another ray, coming or incidenting on the surface in that orderly or regularly manner. But due to the uneven nature of the surface, the reflected rays are scattered. The reflected rays are scattered. So instead of it reflecting in that orderly manner here, no. The reflected rays from individual rays are scattered, crisscrossing one another. So they are not even, or the reflection isn't orderly as we saw in regular reflection. But here, the reflection is scattered. But each of the incidents and its corresponding reflection obey the laws of reflection. Now, so we have light incidenting in that orderly or regularly manner, but the reflection is irregular or uneven. And because of this, no image will be formed. There wouldn't be any formation of. So, because the reflected rays are scattered, no image is formed during irregular reflection of light. So when you look at during sunny days, there is no, even though there is sunlight which incidents on us and then reflects, but because as our body contour is irregular, there is no formation of image. Sun incident on the ground reflects, but because the surface of the earth is irregular. There is no formation of image. However, should the same sun beam on the surface of a calm water, there will be formation of image of the sun and of the cloud. You will see the image of the sun, the image of trees around the riverbank, the image of the cloud in the water, telling you that for smooth surfaces, there is regular reflection occurring. But for the surface of the earth, because the earth surface area is uneven, there is diffuse or irregular reflection, and there wouldn't be any formation of images. Okay, so this one does not bring about formation of images, whereas this forms virtual image. However, this one also has its importance. Irregular reflection also has its importance. Can you share with us some of the importance of irregular reflection? If you have any idea concerning the importance of irregular reflection, please share with us. Anybody? Lenny, I put it to you.
Sir,
Do you have an idea concerning importance of irregular reflection? You have no idea.
yes, sir.
Okay. You see, because the surface of the earth is irregular, what brings about the irregularity? On the surface of the earth, there are stones, rocks, sand. There are trees, river bodies. Mention them. Pisabia is there. Lenny is around. Mami Owusua is around. Eva is there. Caleb, Faith. So we have we have chairs, desks, all manner of objects and people with different shapes and different cross-sectional area. And that is what makes the surface of the earth irregular. Due to this irregularity, the rays from the sun beam in the morning, and then the beam of light incident on the surface of the earth with this irregular shaped surface area objects. So because this surface is irregular, the reflected rays will be scattered in all directions. And this is the reason why no matter where you find yourself, light from the sun will still reach you. So because of the irregular nature of the surface of the earth, the beam or rays from the sun, when it's incident on these surfaces, is scattered or reflected in different directions, so that no matter where you find yourself, light would still reach you, so as to enable you see. So that is what irregular reflection is, what helps us to see. Okay, you see, even if you are hiding under a canopy of a tree, if it's day, you will still get some light and you will manage to see. If you are hiding in a room, no matter how tight, airtight, how there is no opening, you will still get some light coming to you. And this is made possible due to irregular reflection of light. Please, is that okay? Hello?
Yes.
Another benefit we derive from irregular reflection is that the sun provides two sources of energy, light and heat. So during the day, we get light from the sun, and we equally get heat energy from the sun. The radiant energy, which is the heat energy, is equally or evenly distributed, as in the case of the light, due to the irregular nature of the surface of the earth. So even though in irregular reflection, there is no formation of images or virtual image, but it ensures equitable distribution of the light and heat energy from the sun. These are the two main importance of irregular reflection. Okay. Please, any question, any contribution? All right. So we've done regular and irregular reflection. And each of the incident and reflected ray obey the laws of reflection, just as this one also. So each one of the incident and then the reflected ray obey the law of reflection. So let's look at the laws of reflection. What are the laws of reflection? And this is something I think you treated in JHS. So I want you to share with us what we mean by laws of reflection. So what is the first law? What is the first law of reflection? Yes. Anybody? The first law of reflection. Caleb, Dela, you are all here. Share with me. Dela, what is the first law of reflection? Dela. Hey, Leonard, are you there? Mamiya. Hey, can you hear me? Okay, Mamiya, go ahead.
Please, the incident ray, the reflected ray, and the normal at the point of incident all lie in the same plane.
Thank you. So, this is the surface. It can be rough, it can be smooth. Now, for reflection, we always draw an imaginary line which is always perpendicular to the surface. So if you are coming to, or if light has to be incidented on the surface, then there must be that imaginary line which is perpendicular to the surface. This imaginary line is what we are calling as the normal. So it is called the normal because it is always perpendicular to the surface. Makes an angle of 90. Okay. So if you have your normal and light is incidented at the point where the normal is, this is the incident ray. Rays must have an arrow at the middle. So if you just draw a line without this arrow, please, it is not a ray. It is not a ray. So if this is the incident ray, when a ray of light hits a surface, whether rough or smooth, it will reflect. There will be reflection. So when good. So this is the incident. This is the reflected ray. Now the first law says that the incident ray, the reflected ray, the normal, or at the point of incidence, lie, okay, in the same plane or the same place. So the incident reflected rays and the normal at the point of incidence, at the point of incidence, all lie in the same plane. This is the first law. 1. 2. The second law of reflection. What does the second law say? Who is sharing that with us? The guys. Speak.
Sir,
Yes. Go ahead.
sir, the angle of incidence is equal to the angle of reflection.
Okay. So angle of incidence is always equal to the angle of reflection. Please, how do we measure the angle of incidence and the angle of reflection? How do we measure it? How do we measure the angle of incidence? Hello, anybody? How do we measure? Oh, anybody to take us through how to measure angle of incidence and reflection? Mamiya, how do we measure angle of incidence?
Yes, I don't remember.
Okay. Anybody else? Anybody else? Okay. Papaya, Snell's law. No. I'm talking about the angle of incidence and angle of reflection. How do we measure? I know. I know for angles, you need to use a protractor. But okay, so let me take over. So the angle of incidence, you see, the reason why when you are doing this, you need the normal is that the angle of incidence, the angle of reflection, the angle of deviation, the glancing angle, or okay, are all measured from the normal. So we take measurements of this angle from the normal. The reason for which you need to draw your normal. So angle of incidence will be measured from the normal to the incident ray. In that anti-clockwise. Then angle of reflection must also be measured from the same normal to the reflected ray. And theory and then practical has it that I is equal to R. That is the second law you stated. That angle of incidence is equal to angle of reflection. So these angles are always measured from the normal. So the angle of incidence is always equal to the angle of reflection. Okay, now this angle. So practically what it means is that this is, if this is I, then this can also be I, because they are equal. Or this is R and this is also R, because angle of incidence is equal to angle of reflection. So it can be II or RR. The value is still the same. Please, are we okay? Class, are we okay?
Yes, sir.
Now look at this angle. This angle from the mirror or from the surface to the incident ray, theta. I am representing it by the symbol theta. This is known as the glancing angle. So theta is equal to the glancing angle, glancing. And the glancing angle is the angle from the surface to the incident ray. Now, if this angle of incidence is equal to angle of reflection, then this angle is also equal to this angle. So if this is theta, this will also be theta. Okay. And this is by, what rule is this? Under measurement of angle, what is this rule? What is this rule mathematically? If this is equal to this, then this is also equal to the, what is this rule?
The vertically opposite angle.
Vertically opposite, they correspond rather. They correspond rather. So for any reflection, so whether regular or irregular reflection, each of it, incident, reflected, incident, obey the laws of reflection. Now let's also understand. So we've seen angle of incidence, angle of reflection, the glancing angle. Let's also look at the angle of deviation. And the mirrors, how do we calculate for the angle of deviation? Angle of deviation. This ray, this is the incident ray coming from the source of light, hitting on the mirror. Now, ideally, if the mirror isn't there, we expect it to move in this direction, continuous path. This must be its continuous path. But because this is here, the mirror, its path has changed. This is now the path of the light. Due to reflection from the mirror, its path has changed. So, can we say the path of the incident ray is deviated? If the path is changing, can we say that the incident ray's path has been deviated? Class, can we say that? Oh, it's a question to the house.
Yes, sir.
Okay, it's been deviated. So if it is deviated, how much is the original part of the light deviated? So determining how much the path is deviated is a measure of the angle of deviation. Okay, so the extent of deviation, of the incident ray of the incident ray measures, or it's a measure. It's a measure of the angle of deviation. So how do we calculate for the angle of deviation? This is the original path. Due to reflection, it has changed path. So this angle between the extended original direction and then the new direction gives us the angle of deviation. Angle of deviation. How do we measure this angle? How do we calculate this angle of deviation? So if angle of incidence is equal to angle of reflection, so if I is equal to this is I, this is also I. Now, what is this whole angle? What is this whole angle? Yes, what is this whole angle?
Please, 180.
180. So if this is 180 and I'm looking for this, let me represent the angle of deviation by sigma. And this is I and I. Then how can we calculate for this angle theta? Anybody to help? This is I, this is also I. We want this angle. The whole angle is 180. How do I determine the angle of deviation sigma? Anybody to help? Anybody to help? Rachel, you are there. Rachel. If the whole angle is 180, this is I, this is also I. This is sigma. There's the angle of deviation. How can we calculate for the angle of deviation? Please, the floor is open to all. Okay, Mamiya.
180 minus 2i.
Exactly. Okay. So when we subtract this angle from 180, we can get this. So sigma will be equal to 180 minus 2i, or 180 minus 2r. So this is how to calculate for angle of deviation by a mirror. The ray is supposed to go straight, but due to reflection, its path has changed. How much has the ray been deviated? The measure of that is equal to angle of deviation. So under reflection of light, angle of deviation is equal to 180 minus 2i. Any question? We are going to apply this in simple calculations. So let's see how we can apply this concept of angle of incidence thing to solve some problems. A minute to get the question. All right. So simple, quick. Okay, so a question for the house. Please, I'm reading. Get ready to put it down so we can try. A ray of light strikes a plane mirror. A ray of light strikes a plane mirror at an angle of incidence equal to 35 degrees. A ray of light strikes a plane mirror at an angle of incidence equal to 35 degrees. I calculate the angle between the incident ray and the reflected ray. I calculate the angle between the incident ray and the reflected ray. Then I calculate the angle of deviation. I calculate the angle of deviation. A ray of light strikes a plane mirror at an angle of incidence equal to 35 degrees. I calculate the angle between the incident ray and the reflected ray. And I calculate the angle of deviation. I think 2 minutes can do. Are we done? Julian, are you there?
Yes, sir.
Okay. Jojo, are you? Leonard. Oh, Leonard is not here too. I hope you are true. Eva, what did you get for the angle between the incident and then the reflected ray? Eva. Eva. Is she here? Okay, Julian,
Yes, sir.
what did you get for the angle between the incident and then the reflected ray?
Sir, 70 degrees.
Okay. Then, Millicent, what did you get for the angle of deviation? Mommy? Mommy, yeah.
Yes, please.
What did you get for the angle between the incident and reflected ray?
Please, I got 70.
Then the angle of deviation.
I haven't yet solved it.
Oh. Okay, Julian, what did you get?
Sir, 110.
Okay, then let's see. I'm coming. I want to share the attendance on the platform. Okay, so I think we can go through. Yes, I think the angle is 70. The angle between the incident and then the so we are told that the angle of incidence is 30. So you have to draw your mirror, draw the normal. Angle of incidence is 30 degrees. Let me use a straight edge. This is the incident ray. Julian, what did you say? Mamiya, what did you say? For the angle between the incident and then the
Sir,
reflected.
for the angle of deviation.
No, for the angle between the incident and the reflected. Oh, okay. The angle
Yeah,
of
70.
incidence is 35. It's not 30. So angle of incidence must be equal to angle of reflection. So 35, 35. So I must be 2 times 35, which is 70 degrees. Then angle of deviation. The angle of deviation, yes, as I just explained, is equal to 180 minus 180 minus 2i. Okay, so here we mean this ray ideally must go straight, but its path is deviated to this. So sigma, which is the angle of deviation, is equal to 180 minus 2 times I, which is 35. So 180 minus 70, which is 110 degree. Now what about the glancing angle? Crispin, what do you think is a glancing angle? What is the glancing angle? Mommy, I know. Let somebody else contribute. Let somebody else contribute. Oh, I'm calling people and nobody. Nanajua, hey. Thank you, Nanajua. Nanajua, go ahead.
55 degrees.
How did you get that?
Sir, please, because the glancing angle and the angle of incidence will give 90 degrees.
Yes.
So we subtract the 35 degrees from 90 degrees to
Thank
get
you.
the glancing.
Thank you. Okay. So another way of even calculating for the deviation is this. Once the angle of incidence is 35, this is 55. If this is 55, due to corresponding angle rule, this is also 55. Now, by vertically opposite angle rule, look at this. If this is 55, this is also 55. So it is 55 plus 55, which will be equal to 110 degree. Please, is it understood by all? Class, is it understood by all?
Yes, sir.
Sir, please come again.
With which part? Which part? Oh, as
Sir, the second one.
the angle of deviation.
Yes, please.
We just saw that for mirrors, angle of Erefa, your hand is up.
Yes, please. Yes, please. Please, I wanted to ask if you could come again with the first one.
Okay,
Why we are multiplying by 2.
Okay, so we are looking for the angle between the incident ray and the reflected ray. So angle of incidence is equal to angle of reflection, R. So if I'm giving I to be 35, and the rule says that I is equal to R, then this is 35. So is this angle. So if I'm looking for the angle between the incident ray and then the reflected ray, it is this whole angle. It is this whole angle. So 35 plus 35 or 2 times 35. Either 35 plus 35 or 2 times 35. Are you okay?
Yes, please.
Okay. Then the angle of deviation.
Yes.
All right. Angle of deviation. The incident ray ideally is supposed to go straight. But due to its interaction with the surface, its path has been changed to this direction. So the angle between the original part and then the new reflected part gives us the angle of deviation. And through our formula, we realize that if this whole angle is 180, then this this angle, which is part of the whole 180 angle, can be obtained by subtracting this angle, which is 2i from 180. So 180 minus 2i. Fortunately for us, we are given I to be 35. So 2 times 35, which is 70, 180 minus 70, 110. Another way of getting the same thing, the same results is this. If this is 35, this is 35. The glancing angle is 90 minus 35, which is 55. Once this is equal to this, then this angle must also be equal to this angle. So if this is 55, this is also 55. Okay, by vertically opposite angle rule. If this is 55, then it is equal to this angle. So this will also be 55. So look at the angle we are looking for, which is the angle of deviation. It will be this 55 plus this 55, giving us 110. So this is a plan B way of looking at the angle of deviation. All right. And now the other thing I want us to look at under reflection of light under reflection of light is when two mirrors are inclined at an angle, any angle, or at some, instead of any, let me use at some specific angles, what will be the number of images produced? So when two mirrors are placed in such a way that the angle between them is 90, how many images will be produced? When two mirrors are positioned in such a way that the angle between them is 180, 180, what will be the number of images that will be produced? When two mirrors are perpendicularly parallel to each other and an object is placed between, what will be the number of images produced? By the way, when two lines are parallel, please, what's the angle between them?
0 degrees.
0. Good. So the angle, the number of images that can be obtained when two mirrors are inclined to each other by an angle theta is given by this relation. It's given by n is equal to 360 degree over theta minus 1, where n equals number of images. Theta is the angle between the two mirrors. Let me ask you this question. If you go to the barbering salon, or yes, hairdressing salon, and there are two mirrors, one behind you and another in front of you. When you look at yourself through such mirrors, how many images do you often see?
So please, sometimes they are a lot.
There are a lot. Specifically,
Please.
Specifically, how many?
When I try counting, I usually get up to 6 or 10.
When there
So
are
it's more than one.
when there are two mirrors, one behind you and another one in front of you.
Yes.
If you have a bigger mirror around, you can even do it. Test it. Okay, let me pick
Your
another.
line is breaking, please.
Can you hear me?
Yes, please.
Let me pick
Yes,
another
please.
view. Mamiya, when you go to search saloons and there are two mirrors, one in front of you, one behind you, and you look at yourself within, how many images of yourself do you usually see?
I see two images. I see the front and then the back. But I don't know.
You don't know. Gabby,
Mostly you see two images.
are you sure? Okay. You see, when you have search mirror's position, it produces uncountable images. And so the first answer, a lot, but the lot is indefinite. You can't count. Now, if the mirrors are placed perpendicularly to one another, as in this case, this is mirror 1, this is mirror 2. Then you can calculate the number of images using n is equal to 360 over theta, the angle between them 90 minus 1. So this will give you 3 images. 3 images. If the angle between them is 180, you get only 1 image, because 180 simply means that it's like joining two mirrors, and one mirror, another mirror joining in this manner and looking at yourself within. You are just creating a longer mirror. So it's just one mirror that is joined. The reason for which you get 1. Now, if the angle between them is 30, 360 divided by 30, of course, you get 11. Okay, so this is the general formula that can be used to calculate the number of images formed when two mirrors are inclined at any angle. Now, if the angle between them is 0, if the two mirrors are parallel, the reason why you have an indefinite number of images is that divide 360 by 0 and subtract 1 and tell me your results. Yes. Who is doing that for us? Divide 360 by 0 and subtract 1. What's your answer?
Please, it's an error.
Okay. It's an error. Okay. The reason why it's giving you an error note. KJC. KJC, your hand is up. All right. The reason why it's an error is that
One more.
now when you have any number divided by 0, what is the answer? Maybe 10 divided by 0.
My God.
Just mute yourself. What is 10 divided by 0? Oh, let's hurry up with the response.
0.
It's not 0. 10 divided by 0. 1
Error.
is an error. Okay. Any number divided by 0 apart from 0 itself is a very large number which cannot be calculated. Any number divided by 0 apart from 0 itself is a very large number which cannot be determined by the calculator. The reason for which you are seeing an error. Let me take you through 1 or 2 examples to understand. Let's pick the number 1. Starting from 1 divided by 10. Then we want to reduce the denominator to 0. So we are reducing the denominator little by little. So 1 divided by 8, 1 divided by 5, 1 divided by 2, 1 divided by 1, then 1 divided by 0.9. This is giving us 0.1. What about 1 divided by 8? 0.1 6, 2. Oh,
0.125.
0.125.
then this is 0.
0.1.
Okay. This is 0.2.
Yes, please.
This is 0.5.
5.
This is 1.
This is 1.
This is 1 point what?
$1.1.
So what are we doing? We are decreasing the denominator, okay, gradually. So we get a value close to 0. So let me jump 0.01. 0.01 would give us 10, isn't it?
Yes, please.
So we are reducing the denominator close to 0. So let me shift to 0.01. 1 divided by 0.01 is 100, isn't it? Then let's take one last example. What are we doing? Decreasing the denominator and then wanting to draw close to 0. 1 divided by 0.0001. At least this, we are close to 0, isn't it? But what's the result? 0.0001. What's the result?
Is
Hello, I'm listening. Class, let's not wait.
10,000. Please, 10,000.
10,000. Good. It means that if we continue 0.000001, we are decreasing the denominator. What is the trend? The trend is that as we get to 0, the figure becomes very large. So by the time we get to 0, then it means that the whole ratio will be very large. The reason for which any number divided by 0, any x divided by 0, we say is equal to infinity. Any number divided by 0, we say it is equal to infinity. Infinity means an indefinite value or number. Class, are you okay? Are we okay? Okay, so if any number divided by 0 is equal to infinity, then when I give you 360 divided by 0 minus 1, this value here is an indefinite number, infinity. Infinity minus 1 is a very large figure. And that explains the reason why when you look at yourself in a mirror, which is two mirrors, which is arranged in such a way that they are parallel, the angle between them is 0, you get an uncountable number of images. Because this ratio would give you an infinite value. So mathematically, any number divided by 0, apart from 0, is we say it's an word. I say there's a word to describe, forgotten. When it come, I'll tell you. Okay, but what is simply undefined? The word the mathematics use is that when you have a number divided by 0, so this is undefined. It's an infinite value. Okay, let's try another question. I'm reading. Two plane mirrors are positioned perpendicularly to each other. Two plane mirrors are positioned perpendicularly to each other. Full stop. A ray of red light. A ray of red light is incident on mirror 1 . A ray of red light is incident on mirror 1 at an angle equal to 55 degrees. A ray of red light is incident on a mirror 1 at an angle equal to 55 degrees. This ray is reflected from mirror 1 to this ray is reflected from mirror 1 and then strikes mirror 2. This ray is reflected from mirror 1 and then strikes mirror 2. I. Determine the angle at which the ray is incident on mirror 2. I. Determine the angle at which the ray is incident on mirror 2. Then II. Okay, II will draw it. II says that draw the ray of light as it is reflected from mirror 2. I draw the ray of light as it is reflected from mirror 2. I determine the angle at which the ray is incident on mirror 2. So we are told that the two mirrors are inclined perpendicularly, in a perpendicularly manner, meaning the angle between them is 90. So we have two mirrors, one horizontal and another one directly perpendicular. The angle between them is 90. Mirror 1, then mirror 2. A ray of light of red light is incident on mirror 1 at an angle of 55 degrees. So we'll need a normal because we are incidenting a ray and we have to measure. So if the normal to mirror 1 is this, then this is incidented so that the angle of incidence here is 55 degrees. Once this is a mirror, when it's incident on the mirror, it will certainly reflect and obey the laws of reflection. So if there's 55, I must also get 55. Once this is also a mirror, there will be reflection. So normal 2, there will be reflection so that laws of reflection would also be obeyed. So we've answered the second part. Now the first part. Determine the angle at which the ray is incident on mirror 2. Determine the angle at which the ray is incident in mirror 2. I'm adding another question. Determine the angle of deviation from mirror 1. Determine also the angle of deviation from mirror 1. Start work. So you are answering 2 questions. You are determining the angle of incidence on mirror 2 and determine also the angle of deviation from mirror 1. 5-6 minutes must do. No way. Hello, I'm sure you are true. Elizabeth, Uncle, Mamiya, Rachel, these days you don't talk. So, what did we get for the angle it makes with mirror 2? Determine the angle at which the ray is incident on mirror 2. What did we make for that angle? Yes. Who would confidently share whatever you had? Just answer, not how you solved it. Okay, Mami, yeah.
Yes, I got 35 degrees, but I doubt that would be correct. So, but that's what I got.
Okay, thanks for sharing whatever you had with me. Yes. Julian, Rachel, Cedric. Oh, Julian, speak. What did you also make for the angle of incident? Hey, Julian. Oh, I have a lot of you here. And Rashid. Oh, Rashida. Rachel, you are here. Papa Yao. Safo. William. Oh. Making mistake is part of learning. I beg you. Let's speak out. Okay, let's. Frida. Frida. Thank you.
Please, I had 55 for the I.
And
Then the I got 70.
okay, let's see. Let's see. So if this is 55, this must also be 55. Angle of incidence equals angle of reflection. If this is 55, then this, I guess, will be 35. True or false? True or false? This would also be, the glancing angle would also be 35. If this is 35, this already is 90. So if this is 90, then the two angles must sum up to what? Also sum up to what? This and this must sum up to, end my statement. This and this must sum up to, oh, what are you people doing? If this is 90, this and this must also sum up to what?
180 degrees.
No. No. If this is 90, then this and this must sum up to 90. So that when I add this and this to this, it will be 180. So instead of in a triangle, adding all of them and then making us, no, the quick way is that if this is 90, then this plus this must also add up to 90, so that when you add it to this, you have 180. So if this is 35, you can get this by subtracting 35 from 90. Quick. And that will be 55, isn't it? Class, isn't it?
Yes, please.
Yes, sir.
So this is 55. So I don't have to add this equal to 180 before I find the unknown. Once this is 90, this plus this must also be 90. So to determine this, I just would have to subtract 35 from 90. I'm there. Now, if this is 55, this will also be 55. Therefore, this will be 35. 35. So the angle of incidence to mirror 2 is 35 degrees. Okay. Then the angle of deviation. What is the angle of deviation? Originally, the ray must move in this direction. But due to its interaction with, okay, Gabby, we shall see. Due to its interaction with the mirror, its path is deviated here. So if this is 35, this is also 35. Vertically opposite angle. So 35 plus 35, you have 70 degrees. Or 180 minus 2i. What is I here? 55. So 180 minus 2 by 55. This is 110. So we are done. And just so simple. So when you understand these basics, we are good to go. Okay, please, any question? No question. Okay, now I just dropped the evaluation form. And we are doing this for physics because usually if your students are asked to do it, it's actually after the whole thing, if you have to evaluate what the teacher was doing, it is so boring. And so a lot of you are not, free doing it. So let's use about, okay. All right. So my attention has been drawn to the fact that the evaluation must be done from next week. So we are going to continue with our lesson. Next week, we'll use part of our duration, Tuesday, to quickly go through this, okay? Now your assignments. I'm giving you an assignment on this. on this. And the assignment is that give me a minute to retrieve the funny assignment I have for you. In fact, you must think through it, else you'll be laughing at the wrong side of your mouth. Okay, please put the question down. Two plane mirrors M1 and M2 are inclined at an angle theta. Two plane mirrors M1 and M2 are inclined at an angle theta as shown. So, meaning I have to draw something for you. M1, M2, plane mirrors. This time not 90, but we are told that they are inclined by an angle theta as shown. A ray of light 1, which is parallel to M1, a ray of light 1, and this ray of light 1 is parallel to M1, strikes M2. So there is a ray of light 1. This ray is parallel to the mirror 2, strikes mirror. This ray is parallel to mirror 1, sorry, and strikes mirror 2. So this is the ray 1. It is parallel to mirror 1 and then strikes M2. Are we there? A ray of light 1, which is parallel to M1, strikes M2, and after 2 reflections, after ray 1 has gone through 2 reflections, becomes parallel to M2. So ray 1 strikes M2, and after it has gone through 2 reflections, what are the reflections? It hits on mirror 2.
So please come again with the question.
I'm coming in. So a ray, 2 plane mirrors M1 and M2 are inclined at an angle theta as shown. So M1, M2 are inclined at an angle theta as drawn. That's the first part. A ray of light 1, which is parallel to M1. This ray is parallel to M1, and parallel lines do not meet. So look at ray 1 and mirror 1, they are parallel. Okay. A ray of light 1, which is parallel to M1, strikes M2. And after 2 reflections, after this ray has gone through 2 reflections, so let me demonstrate the 2. This ray hits a mirror M2 and it will reflect. So this is the first reflection. Then after the second reflection, the ray is parallel to M2. So the second reflection of this ray must be parallel to M2. So this is light 1 and then light ray 2. So after 2 reflections, the ray 2 becomes parallel to M2. The ray 2 becomes parallel to M2. Now find the angle theta between the 2 mirrors. Find the angle theta between the 2 mirrors. Find the angle theta between the 2 mirrors. That is your assignment. So 2 plane mirrors M1 and M2 are inclined at an angle theta as shown. A ray of light 1, which is parallel to M1, strikes M2. And after 2 reflections, the ray 2, after 2 reflections, so 1, 2 reflections, the ray 2 becomes parallel to M2. Find the angle theta. Okay. Please do not hint in solving the question. When 2 lines are parallel, it means that the 2 lines have the same slope. If this line is parallel to this line, look at the 2 rulers. If this is parallel to this, then the angle, when I draw a horizontal to all of them, the angle each rule makes with the horizontal must be the same. So here, if the 2 rulers are parallel, then they all must make an angle of 90. They can be parallel when one is like this and the other one is like this. So when 2 lines are parallel, it means that they have the same slope or gradient. So if M1 is parallel to M2, then this angle here between M1 and this mirror must be the same as the angle between ray 1 and the mirror. So if this is theta, this must also be theta. Another hint. Mirror 2 is parallel to ray 2, meaning the angle between mirror 2 and mirror 1, which is theta, we must have the same angle between ray 2 and mirror 1, theta, because ray 2 and mirror 2 are parallel, so they should have the same slope. So this is just a hint of what to do. When you have this, I think you must be able to think through and then get the answer for me. Whoever gets this right or correct wins an award. At least you can win a traveling visa to Dubai after COVID. So try and then get it right. Until Tuesday. In fact, this is why I draw the curtains on today's meeting. Thanks for your time. Please, I'll be waiting for your assignment. Those of you who are not fond of submitting assignment, please do so. Okay, in learning, as you get it wrong, you learn from it and move on. So do not fear submitting an assignment and then getting it wrong. It's part of the learning and teaching process. So until Tuesday, may the good Lord be with you, and then bye-bye. Don't forget to subscribe and then share my video. Of course, it will be posted. Until then, take care. Bye-bye.
Yes, sir.
Bye.